Hey everyone, thanks for coming so early today to listen to me talk. I want to talk about communicating across Ethereum's parallel universes. So a little bit about myself. My name is Bo. I'm the technical co-founder at Polymer. I previously worked as a core database engineer at a few different startups before transitioning into Web3. So to start the talk, I want to go on a little bit of a adventure. So let's say we're traveling through space. We arrive at this really futuristic looking city. There's a lot going on here. And we get led into this room. And in this control room, we have a bunch of guards monitoring a screen. And what's on this screen? On the screen, we can see that there's multiple timelines that are forking off from a main canonical universe into many different parallel universes. At this point, we're probably wondering, are we stuck in a Marvel movie? Who here thinks we're in a Marvel movie? Raise your hand. Okay, pretty good number. Actually, no, we're on Ethereum. Let me explain why. So it might be an interesting analogy here. So in the context of Ethereum, we have the sacred timeline, or the finalized history of Ethereum. And in the diagram here, we can see that Ethereum is comprised of two parts. One part after the finalization threshold, which is roughly 12 to 16 minutes. And before that, we have a number of Ethereum forks that are forming, from the head of the chain to the 12 to 16 minute mark. And this is due to how Ethereum consensus works. So a quick high-level overview of how Ethereum consensus works. We can see that it's comprised of two algorithms, LMD Ghost and Casper FFG. One is a fork choice rule, and one is a finalization gadget. And what this allows Ethereum to do is to maintain liveness, meaning that Ethereum is always able to produce blocks, and those blocks will eventually be finalized by the Casper FFG algorithm. But what this means is that there is a canonical Ethereum timeline that exists throughout, but there's many parallel universes that form before the finalization threshold is reached. So now I want to talk a little bit about rollups and how they work. So many of you in the audience are familiar with the rollup construction. What I want to point out here is that every rollup builds its blocks off of some point in the layer one history. This is a contrived example. In the example here, we can see that Arbitrum builds its blocks off of a depth of 75, Base builds its blocks off a depth of 15, and Optimism builds its blocks off of depth of 12, meaning that all three rollups are producing blocks at the same time, yet off of different points in Ethereum history. Now, what happens during a reorg? A reorg happens when a rollup is building off of a history of Ethereum that does not get eventually finalized. Think of this as a parallel universe that eventually gets pruned in favor of the canonical timeline or the sacred timeline. Well, how often do these layer one reorgs happen in practice? If we rewind the clock, go back roughly 3 years, we can see that there was a 7-block reorg in May of 2022. This doesn't happen very often. In fact, it happened so infrequent that there was many different articles written about it during that time. Now, does this mean that L1 reorgs don't happen at all? If we look on the bottom, we can see that L1 reorgs happen quite frequently, multiple times a day, but the depth of the reorg is very shallow, usually 1 or maybe 2 blocks. So what does this mean for rollups? I want to use this framing to help us think about what rollups are mostly impacted by this behavior. Once again, we can see that each rollup here in the example is building off of a different point in Ethereum history. But all rollups in production today are building blocks off of a depth of generally at least 10 blocks or more. On the right of the diagram, we can see that in the future, if we have based and atomically composable rollups with L1 state, perhaps Spire, that these rollups will be much more subject to these reorgs because they're building off of the latest Ethereum state or the head of Ethereum. So we get this chart where we have extremely high risk at the head and asymptotically low risk as we go down the chart. So with all this context, now let's talk about how we can safely communicate across all of these parallel universes. I drafted an RIP 7789, to describe a few safety invariants that we must enforce to enable safe communication. The first invariant is somewhat familiar to folks that watch any sort of time travel movie. The past can communicate with the future. So you might have watched a movie where someone leaves a love letter in a mailbox, and then maybe their significant other, many generations later, finds the mail in the mailbox and is able to read it. Unfortunately, the person in the past can't communicate, the person in the future can't communicate with the person in the past. And the reason for this in the Ethereum's context is this can lead to inconsistent reorg behavior, meaning that a reorg can touch the future without touching the past node, resulting in a safety invariant, safety violation. The second rule is that we cannot communicate across different timelines. This is as if you're in one universe, you cannot communicate with someone in another universe unless you travel between universes. And in the rollup context, it would be if the rollup is building off of the one L1 history versus the other L1 history. And communicating across these two results in a safety invariant because at least one, either one or the other, will eventually end up reorging, and only one Ethereum history can be finalized. The third invariant is that any linked L2s, and we call this a contingency link, must reorg together or not at all with respect to the cross-chain transactions that have happened. We'll describe what a contingency link looks like a little bit later in the presentation, but this means that you get consistent behavior across rollups that are communicating with one another, essentially all or nothing reorg behavior. The last invariant is that replaying of reorg transactions is not allowed. And what this means is that any cross-chain transaction that was based on reorg state may be based on source information that is no longer valid post-reorg. So this is also a safe, this is, yes. Oh, okay. So let's talk about what the protocol that we actually get when we enforce all of these safety invariants. We get this contingency DAG, or directed acyclic graph, that's created between rollups. So in the example here, we can see that we create a contingency link between optimism and base. We have messages C1, C2 that we are relayed to base based on this contingency link. That means that these two messages are only valid if this contingency link itself is valid. Now we get a little more complex. So we have 3 rollups now, and we have 1, 2, 3, 4, 5 contingency links that are formed, and we can see that the original C1, C2 creates this dependency graph all the way down to C3, C4 on base. Now what happens in a reorg? In a reorg, all of these contingency links are now considered invalid. This rolls back the state all the way back to C1, C2 on the original chain. All the previous messages that were sent based on these previously valid contingency links will also revert due to the contingency links themselves being invalidated. So to summarize, we can't communicate across universes. We must ensure that reorgs happen together, all or nothing, for linked rollups. We can't communicate from the future to the past. And we must reject the replay of reorged cross-chain transactions. So if we give Dr. Strange the RIP 778 algorithm, we have him wave his hands a little bit, we can bring all of Ethereum's many universes together as one. Feel free to contact me if you're interested in discussing this topic more or interested in building with us cross-chain. The product that we're working on currently is called the Prove API, where we're able to generate cross-chain proofs for applications that want to build multi-chain. Thank you.
Yeah, and with